presentation. We're going to present José Manuel Mulet, who's going to talk about real ecology and the future of agriculture. He's a professor and research of the Polytechnic University of Valencia. One of the lines of research of the Institute of Molecular Biology of Plants is to develop plants resistant to droughts and cold. He also runs the Master of Molecular Technology. He's a scientific communicator. He's produced the books Ecologism, Real Ecologism, Eating Healthy, and What is Healthy Living. And he's the author of many articles and papers, and he's taken part in many conferences, both nationally and internationally. We are lucky, and we're really lucky to have him back here in Inversolar for the second year with Professor José Manuel Mulet. Please welcome. Thank you. Whenever you're ready, it's your turn. Second year? Second or third? Yeah. So maths is not my strong point. Yeah. Okay, here's the presentation. The production of food from the point of view of ecology or environmentalism. One thing is eating, it contaminates. Let's see. Everybody to be alive has a consumption of energy. That means that if they're lying down in the bed without doing anything, their heart continues to beat, their lungs continue to breathe, the kidney filters, and that consumes energy. Imagine that all the energy consumption you converted into petrol. As you can see on the screen, me from memory, I can't remember. It's more or less, if you calculate the quantity of energy is necessary for a person who's 40 years old and 70 kilos of weight, you need 0.2 liters of petrol per day, whereas a woman who weighs normally a little bit less, has a metabolism a little bit lower, needs 0.16 liters of petrol per day. Well, if you consider that the most normal that a person lives is 80 and a woman 85 years, that's during your life you will have emitted 16 tons of CO2 or 15 tons of CO2 in the case of a woman. We contaminate a lot. Why? Because here we've got the plants doing photosynthesis, taking CO2 and emitting oxygen. We do the opposite. We use the oxygen, and we use the energy and emit CO2. Therefore, we have to take into account also another thing. If we were able to consume gasoline, we would be much more efficient energy-wise. But petrol's really boring. Normal, super, diesel, no, you wouldn't need anything like that. Let's make it a little bit more fun. The problem is that with food, as we're thermodynamic machines, we are very inefficient. We need food. The food has an energy cost for production. We don't take advantage of all the energy of the food. We leave a lot of waste. We produce a lot of waste. So agricultural production and feeding ourselves contaminates. We also have to say that now maybe only agriculture is contaminating. The European Union, the main problem is agriculture is contaminating. The figures. What is consuming is the production of energy. And the energy contaminates, but 12. Oh wow! Now I don't have to invent the figures anymore. Where were we? I managed to get the energy right, 75% right. I was inventing the figures. As you can see, the main limiting factor is the production of electricity. It's true that the agricultural production of food is 13.8% of emission of greenhouse gases. Can we do something about that? Can we change habits? We're not going to put the blame on other people always. Is it in our hands to change some habit to be able to minimize that impact? Whether we like it or not, we're going to have to do it. You're a thermodynamic machine, not very efficient. Well, the Lancet magazine in 2019 published the Lancet Planetary Health Diet. It's a proposal for a diet taking into account health, environmental and biodiversity aspects. The diet that they brought out was an example of a flexitarian diet. Strange name. I went to a seminar when they talked about a non-practicing Catholic. So flexitarian is like a vegetarian, not a non-practicing vegetarian. It's a diet with mainly vegetable products where you may have meat from time to time, then other products derived from animals, milk or eggs. It's not a magical solution. A kilo of beef doesn't have the same impact as a kilo in Europe as the same as in Uruguay, where they form part of the ecosystem of the Pampa. Talking about the impact in both of those places is different. Very criticized aspect of that diet, because it doesn't talk about the production of potatoes. Apparently it's the worst thing that you can have. In Africa, the base of food is a marioke. Go to Africa, you can't buy, America, you can't buy it because it contaminates. It's not the case. Then we have to take into account where the food is produced and where it's consumed. Therefore, well, it's an approximation, but its approximation is not too clear. There are many other factors. For example, it is true that a diet mainly with vegetables is a diet which has a lower environmental impact, because an animal consumes vegetables and doesn't fix CO2. So if you use vegetables to feed the animals and you don't feed those animals, then you're losing efficiency in the process. However, now it's fashionable to be vegan. What's becoming fashionable is the vegan label. So they're not necessarily good for the environment. That is to say, texturized soya or famous vegan hamburgers, which are vegetable-based foods, doesn't necessarily mean that it is a guarantee for environmental friendliness. And all that energy, all the processing that's required for soya to look like beef, we've got to put a lot of additives, a lot of processes, chemical processes, which are quite aggressive, and needs a lot of energy is needed. You've got a lot of ingredients. This, from the environmental point of view, a vegan hamburger is not an advantage, however much we like vegetables. To get an environmental advantage, you need to have vegetables that look, taste and smell like vegetables. And eating a vegan hamburger is not benefiting the environment. Now we're talking about labels. We go to the different supermarkets and you have food that looks like a general from North Korea. It's biodynamic, it's proximity, plastic-free, pesticide-free, without additives. Of all those labels and brands that there are in the market. There are many. Are there any that guarantees that your food is more environmentally friendly? The answer is a clear no. Now, there is no label that guarantees that your food is more sustainable or environmentally friendly. Why not? Because there's no label that takes into objectivable factors, carbon footprint, water footprint, or nitrogen footprint, for example. The organic production label, which is supposed to have a lower environmental impact, is not true. If you read the rules, it only says that the pesticides that are used and the fertilizers used must be natural, nothing else, and they must be authorized in the rules and the standards. The spinosad is an organic agriculture pesticide. It destroys the pollinizers and the bees completely. Anyway, of course, as it doesn't include parameters like the carbon footprint, the water footprint, you see that you have organic products that you can find in any product in supermarkets from New Zealand. From an organic point of view, better to have them closer to home. This fashion to use the environmental labels, it's the opposite. It's what allows us to do a more efficient process. 100 years ago, who would have said that in 2021, the areas with the largest production of vegetables in Europe would be a desert where they filmed westerns, and Yul Brynner was around here, or a place which is below sea level. The main vegetable producing areas are Almeria and the Netherlands, areas where nobody who had money to buy land would have bought that land there 100 years ago. Now, there's a thing that's quite curious. You know, there's a legend that says that the Great Wall of China can be seen from space. It's not true. This is a photo from a satellite where the Great Wall of China is supposed to be. Yeah, well, how the small is it? How are you going to see that? You can't see it from space. But the greenhouses of Almeria can be seen perfectly. And now, before saying the greenhouses are ugly, I think they look lovely. But you can see them from the Meteosat. It's something you shouldn't be ashamed of. Quite the opposite. So, looking from the International Space Station, that's where all the fruit and vegetables for Europe is being produced. And it's not ugly, it's beautiful. But that's a question of tastes. The idea that we have is a problem of communication. The agricultural production, depending on technology, is more efficient, more environmental friendly than natural gas. Yeah, we're talking about biological control. The idea is the vision of agriculture. The average citizen still thinks that agriculture is something like that. It's sort of a Garden of Eden where growers is a gentleman with a straw hat around 70 years and a checkered shirt who calls the cows by their names, and he's got his straw hat and he's picking tomatoes, and no, that's not it. No, life in the country's never been easy. These neo-rurals no. Yes, this is definitely not reality, no. Life in the country, when there was no technology, it wasn't an easy life, nor was anything given for free. Now we have to use technology, as in any other human activity. All it does is makes work easier. Can you imagine not being able to use the internet with all the data that's controlled, and can't use computer because they become dependent on Windows or Bill Gates, and they have to go back and use a typewriter? Can you imagine that? That's a lot of growers are doing that every day. The production must be natural and all the rest of it. The image that we have is in any human activity, any trade, a grower is a person with access to technology, and he uses it to make his work easier. And when the work is easier, a grower has a more efficient production. It's easier. It's a better price, a more competitive price that more people can eat, lower social gap, and more environmentally friendly. When you produce expensive food, your production wasn't very effective. In fact, in the majority of food products, the price represents energy consumption, which means CO2 emissions. The most expensive food are the ones with the worst carbon footprint or water footprint. And in fact, one of the things that has been what's advanced most, biotechnology. We wouldn't have all these varieties of tomatoes. You think this has come out of the Garden of Eden? Did they have raft tomatoes? No, they didn't. They're very recent, the 70s. In fact, a very obvious example, all the production of sugar in Europe depended on sugar cane, and that implied trading with colonies and slave labor until they started becoming independent. The trading was blocked. They started producing sugar from beet. The problem was beet had very little sugar. In only 100 years, using genetic breeding techniques, they've managed to duplicate the sugar content in sugar beet. And for 2 centuries, they have managed to avoid depending on sugarcane thanks to sugar beet. There's more technology. We've got transgenics, copy and pasting from one organism to another. Oh, goodness me. Oh, that's terrible. You said transgenics. Oh, that's a crime. It's a sin. In Europe, we only allow one type of transgenics to be planted, but over 100 can be imported. Slightly hypocritical there. Everybody says we don't want transgenics, we don't want transgenics. Well, biotechnology, the advances, agricultural technology advances have taken place very, very quickly. In fact, these are data from 2015. To see we don't want transgenic, the use of surface area has been growing year after year, and with very high figures. Here you can see 85% of soybeans, 75% of cotton, 29 of corn, and 24 of they were transgenics. So, not wanting transgenics, we tend to. It's also true that a lot of this rejection is due to the fact that the market was covered by 2 areas: resistance to insects and resistance to pesticides. The consumer only had corn or soya, which was slightly cheaper. But color, smell, taste, it was exactly the same, transgenic, and so therefore it was easy to say no to it because you didn't see the improvement. Now, careful. There is an environmental improvement. This is a field of a trial of corn. It's the only one that is sowed in Europe, which is resistant. On the right, that hasn't been treated with insecticides, but it's transgenic. For that corn to have that, to look like that, using transgenics, you've avoided using a lot of pesticides. Transgenic corn has saved the environment tons and tons of insecticide. It's not just the the impact of insecticide, its production, its transport and application. Thousands of tons of CO2 which we've saved the atmosphere thanks to using transgenics. It's something that's never spoken about or said. In fact, there are calculations that have been done. These are the benefits. I've only found the data for one country, which is Colombia, with varieties resistant to insects. They've saved 75% of the pesticides that were used. And tolerant, they're talking in between a 20 and 30%, which they can't change. And now we also have transgenic animals, which is transgenic salmon, which grows more quickly, lower impacts, and also we have new breeding techniques. I'm not going to go into detail there because I've got the moderator standing up looking at me. We're going to talk about CRISPR and that's it. We've mixed genes for many times. We had grafting where we mixed genes. CRISPR, which was invented in Alicante, and I'll go through that when I'm going back to Alicante. It's editing the genome of the organism. We do not put other genes from one place to another. There are many varieties which are commercialized. In Japan, there are tomatoes which are being commercialized. In the Biotechnology Congress, we talked about this. These are the tomatoes which are being sold in Japan. And the most important, and we can also use CRISPR for pest control. All the pests which are being used for pest control using CRISPR, we can use it much more efficiently. And thank you very much indeed. I'm not going to carry on. It's been a pleasure. Don't go away, José Miguel, please. Let's give the people who are watching us to ask some questions. It's always a pleasure. As I saw you there, you were right. 3 sessions, but not in this format. The format of promotion of solar greenhouses. Any questions for José Miguel? Okay, now the microphone's coming up so that you can listen to him from internet. José Miguel, I'd like to ask you about the image of the Great Wall of China and the greenhouses. I always said they're very nice and I love them, but I'm not objective, I'm very subjective. We'll leave that for later. My question, if there weren't any greenhouses in Almeria, if there weren't greenhouses for those of us who don't understand, how would the diet of a human being here? Who could eat a salad? It would be a luxury product? I'm more pragmatic. If there were no greenhouses in Almeria, they would be in Morocco or in India, but nobody's going to say no to salads or vegetables. If it weren't here, it would be produced somewhere else. That's what would happen. The hypothesis, what I want to do is to value the importance of the protected crops compared to the fact that natural crops are open air. The problem with open air crops, it's more limited because it depends very much on climate conditions. Take into account that vegetables are a very delicate crop regarding the consumer. We have to take into account that the consumer wants nice vegetables. No supermarket wants a damaged pepper. So getting pretty tomatoes, yeah, it's not easy. It's difficult. That means that if you produce the vegetables outside with all the risks, and knowing that the greenhouse that the supermarket is not going to buy them unless they're pretty, you lose a lot of the production. The price would go up. Tomatoes would be a luxury item. The environmental impact would be incredibly high. Question answered? Good. Another question? What Francisco wanted to explain is that from outside we don't see what's inside. Yeah, I've heard that many, many times, yeah. The impact's tremendous. I can't hear him. Tell them from the International Space Station. It looks really nice. It's all a question of perspective. You said this in your presentation when we're talking about plastic containers for fruit and vegetables, transport, carbon footprint, transport of fruit and vegetables. Everything that's bad apparently is caused by fruit and vegetables. What is this sector doing wrong? We have another example in the Mar Menor, which is the inland sea of Murcia. They're always blaming agriculture for the problems there, and not talking at all about tourism, not controlling wastewater. I think growers don't complain enough. They should complain more. There are many examples. For example, a chain of German supermarkets was going to stop buying from the inland sea of Murcia. When we had the pepper crisis here, the same supermarket said they were going to stop buying from the German producers. And yes, I am not going to say it because it's going to smell bad. I think the grower should complain more. We're always the weak link of the chain. So we'll tell them so they can complain a little bit more. Jose Miguel, we're going to have to finish here. Thank you very much. A great pleasure. And we'll see you next year. Thank you very much. We've talked in this greenhouse about biological control. We're going to see a very short video now.
Natural esencial para fomentar la biodiversidad y la producción sostenible de alimentos. Es muy eficiente en el control de plagas y garantiza una excelente calidad y sabor de las frutas. Poblaciones.
This is one of them, the programs carried out in the Inversolar program to make this known to the consumers of Europe. We're going to continue now with Paco Calvo, and his presentation is Plant Sapiens, a future of Paco's been a researcher for the Fulbright program in San Diego. He carried out his doctorate in Scotland as he studied in the Ramon and Cajal program. He's the professor of logic and philosophy of science in the Department of Philosophy, where he directs MINT Lab, the laboratory of minimal intelligence, specializing in philosophy of cognitive science and plant neurobiology. He does many more things. He's prepared for this Congress a video. It's really interesting, and the most interesting thing is to meet him and say hello. And Paco, welcome. Thank you very much indeed. Welcome. Thank you. Okay, I'm going to stay here. One of the things that the person who introduced me said, we have a laboratory of minimum intelligence, and the peculiarity is it's in the faculty of philosophy. How do we explain all that? Because we work in vegetable intelligence, planta sapiens. We want to understand the intelligence of plants. We do it from a perspective, theoretical perspective, more ample and biological vegetable biology. And we do all this. See if we can see it. No, we can't see it there. We do it from a project which is used in our laboratory to use projects of bio-inspiration, to use the robotic and artificial intelligence. So we see how do we get all this together, phyto-bio-inspira, thinking in the intelligence of plants. We can learn many more things with the intelligence of plants. If you think about it, well, there's something here, the guided visit that we did with Lola before. There's a very simple way to understand what this is all about. It's common sense. If we apply common sense, it's quite a lot easier than it appears. When we think of why the finance that we get for the lab comes from the Department of Defense of the United States and the Department of Defense Naval and Research, what is the interest they have in plants? Well, if we think about plants of another way, from another perspective, we can understand them in a completely different way. Here we've got a video. You can see a root. This is a root of a rice root, and you can see the one up the top is it's a wild plant. You can see the movement it's carrying out. The movement is going around. It's called circumnutation. The plant's going around in this exploratory move. It's exploring the territory. And see look at the plant at the bottom. If we repeat that, it is a mutated plant which doesn't allow the plant to carry out this exploratory movement. It grows in a spiral without doing anything intelligent. It doesn't explore. Now, what happens if we explore? Like the plant we have above, we can generate, in this case, bio-inspiration for robotics from the perspective of how a vegetable behaves in its surroundings, so you can get much better results than you're using in robots with animals science. So we're looking at a golf cart with wheels which is going along the surface of Mars. It looks like a sort of a geologist who's going in exploring the geology of Mars. When the rover moves, it comes lots of ditches, a bump. There are many things that can happen. So the worries that the engineer designing this robot has are worries that are exclusively engineering worries. How the robot moves, how we can get it to move from one way to another to get over those obstacles. What happens when we think about bio-inspiring our robot with vegetable models? Maybe we kill two birds with one stone. The plant, when it grows, doesn't move. We understand vegetable intelligence and thinking, what can the plant do to achieve its objective, which is nothing else than growing. So therefore, it achieves its objective. There's a ditch, it grows above the ditch. So we're talking about this. It's a very simple thing of changing the chip. How can we bio-inspire our robot to achieve our objectives, to resolve this problem using the nature of growth itself? And the growth is the answer to the problem. This is an example. We can bio-inspire our models with plants. The objective, here you can see, for example, a robot which is bio-inspired. It's growing. The one on the left, which is moving in this end using circumnutation, it can go around those obstacles. The one on the right can't do that. Like the root that had a genetic mutation stays where it is. The morphology the constitution, the way the robot moves, gives it the answer to the problem. So what we have to do is to inject that answer into the software. We have to anticipate what the robot has to do. No, turn left, turn right. In this way, what we're doing is providing the autonomy needed, bio-inspiring it to the autonomy of a plant. So how does a plant do what it needs to do for itself, by itself? Regarding robotics, but robotics and artificial intelligence, we can put it to the service of what we do in the greenhouse. So when we think about greenhouse plants, of course we can observe them from outside, and we can use time-lapse. In the laboratory we can use time-lapse videos, take a photograph every minute, every 5 minutes, and when you set up a time-lapse video, you can see that behavior and give it that sense, understand the vegetable behavior through its observing its response, how it explores the terrain, if it's a root, for example. But we can also register internal activity. We can put very sensitive sensors that allow us to register electrical activity with the plant. We can put an electrode, a sensor in the vascular system of the plant. We can see what's happening inside, and that can go to such a sophisticated level. So a magnetic resonance or a PET, very specialized techniques in space and time to register internal activity. So a Homo sapiens, when we change Homo sapiens for plant sapiens, there is no difference. We just change the model, a model that doesn't move, that grows, but we can use the same techniques for internal observation, not just observing the external conduction behavior of the plant, but see its internal behavior. And we can see the profile of the electrical physiological response. How do they fire the cells? The same as the neurons. We're talking about Homo sapiens, animal intelligent. We can study the neuronal system, seeing what's happening in the brain. We can use an ECG. We can do the same thing with the plant. We can see what's triggering. We can see we can understand that plant looking at the responses. And all this can be done. Tomography, magnetic resonance, that doesn't give us what we need exactly. I'm just going to get a bottle of water, have a little drink. And we don't get everything we need. What do we need apart from all that? We need the capacity to approach the plant, to approach its behavior, not just looking at the substrate, physical substrate, not just electrical, physiological behavior. This is the key we were talking about. We don't just have to think about the activity for reductional, mechanical, or activity, molecular, cellular activity. Where is the plant? What is it interested in? What's happening out there? So only approaching the behavior of the plant, with the interaction of the plant with its surroundings, plant surroundings, that's how we can understand it. The important thing is that we are able to get into the shoes of the plant, so to speak. If we want to make agriculture sustainable, we have to make the mental effort to get into their shoes. What is important for them? To understand what's important for the plant, not only do we have to try and understand the electrical activity, the internal electrical activity, electrophysiologically, what's happening to the plant. For example, we need to understand the context, the surrounding that gives it meaning to the life, to the manifestations that we can see. It's not just a reductionist system, it's not mechanized. So we see the slide that we have here. What we want to say here is that we have to accompany that research of the part below. It's the vegetable physiological, with it in the surroundings. The context is so important as what's happening inside the plant itself. That's fundamental to understand it. And now We do this from Faculty of Philosophy, working in cognitive science, which means we have to join vegetable biology with cognitive science. We have to carry out the pedagogy in this field. We're not just doing vegetable biology, which is extended or environmental. We're going towards the study of the plants from cognitive science, not from physiology. That is the only way that we can understand what a plant is trying to extract a meaning from what's surrounding it. Another way to say this is we have to understand the plant as a system of information processing, or an information processing system. The plant is processing information, same as humans, same as other animals. How a rat behaves, a lab rat, a dog, a cat, ourselves, we think of ourselves as processing units. Now we need to study the plant where the information is flowing from it, a system of information processing, not just a system of substance transport, and sugars, minerals, waters, going through the xylem and the phloem that connect the body of the plant. Those highways are informational connectors. They provide answers to the questions. So the plant looks at all its environment. This is happening up here, this is happening down here in my roots, and it provides an integrated and holistic response. Why can't we go towards the understanding of the vegetable kingdom from the finding in a global sense, holistic sense, for factors which are relevant to the plant from the plant's perspective. So to be able to carry out sustainable organic agriculture, it's important to understand the plant. We can't see that very, very well, but maybe this is a greenhouse, a project which has been carried out in Switzerland, and it's very, very interesting because when we talk about electrophysiology, the plant's electrical physiology, there are systems. We can have a system of sensors and biosensors that can extract that information from the plant, which enable you to act as an early warning system. You can register that, interpreting the internal activity of the plant. You can see when there is a source of stress. The plant is subjected to a sort of stress, thermic, chemical. The plant is going to dictate. When we learn how to interpret that information, the electrochemical information which is going through the vascular system, the plant anticipates, hey, something's going to happen here. Let's set up early warning systems to realize what's going on in that environment. So if we're able in these models to set this up in last generation greenhouses, the capacity to algorithms that we train on that information, feed those neural networks, those sensors that we see in the plant, in such a way we connect the system, we automate the system to regulate the amount of nutrients they need, the irrigation, light, lighting, relative humidity, whatever it is. These are parameters which are potentially relative. We can adjust it in real time to anticipate this future stress, which the plant is telling us it's going to suffer. They're going to suffer stress, and we read that electrochemically through the sensors, and we are able to find a solution to the problem before it appears. That capacity to put us in front of that, to anticipate the contingency of the surroundings, to find out what the requirements are through the activity that we're processing from that. The plant's going to tell us what's going to happen, or before it's too late. In other words, that's one of the things that we can do. And of course, when we're talking about the concept of processing the electrical activity of the plant, we have to use it from the in vegetable intelligence. We understand the plant to be an agent with its interests, its requirements. The plant wants to be one way or another. Remember the root that was exploring the terrain. It doesn't grow simply downwards. It grows intentionally. It decides one route and not another according to its particular interests. And as a function of that, integrating that vegetable intelligence in the greenhouse, we can generate possibilities of optimizing the yield, plant stress, etc., etc. There's information here. This is the perspective that I'd like to insist on. As we were saying in Lola and the Gardi visit, to put ourselves in the plant's position. If we are able to think about something and see what it's interested in, that picture's being seen very well. We're wasting time and money, and the easiest way to do it is using common sense. Put yourself in the plant's position, think that it's what's relevant for it, and you can take measures which will be environmentally sustainable. Let's have a look at an example. Reduction of stress with thinking about sleeping, the benefits of sleep. When we think that what we need is sleep, we know that, for example, sleep can be induced through melatonin, which we secrete anthropocentrically, in the animal kingdom we're the best. Of course, it's something that I do, and I only think that it has of the benefit for myself. I don't think about the benefits, how simple it would be. And what about the plants? Why don't they benefit from sleep? They rest. What does it mean a plant can sleep? But it's not a metaphor. Plants synthesize their own melatonin, and we think that we have the exclusivity there, and we think it's just ours. It was identified in cattle in the 50s. The pineal gland secretes it. We take melatonin pills when we can't sleep, and we don't realize that a plant, that molecule, benefits it. Until 1995, we didn't discover phytomelatonin, and when it was discovered in 2004, 20 years ago, we coined the phrase phytomelatonin. It's not just ours, it's phytomelatonin, the same molecule. We didn't think we need that jump, common sense. If the plant biosynthesizes its own melatonin, isn't it because it's interested in that? And thanks to that, an intellectual leap we've taken, all that research into the factors and the model and the role that phytomelatonin carries out, and a number of physiological responses that plants have. This is a plant that we have in the laboratory in Murcia. Now we know that leaves fold at night. Plants anticipate when the sun goes down. Before it goes down, they start closing the leaves, and before it comes out, they open up. So there's a very sophisticated pattern there, working 24 hours. But melatonin, phytomelatonin, enables them to synchronize very well with those patterns and those rhythms. The rhythms that provide important information for them. We can induce it. We can induce jet lag. Jet lag you get when you go over the pond to the United States. You can induce that in a plant, changing photoperiods. You change the time zone. You put it in another country. It's going to start opening up and closing when it's not time to do that. It's suffering from jet lag. The phytomelatonin will enable them to synchronize those patterns to reduce stress. And there are many other types of stress. Phytomelatonin is going to enable them to regulate the opening and closing of the stoma. It's going to mean that there are going to be fewer possibilities of bacterial infection. There are many examples where that research can be useful for sustainable agriculture. We only have to realize we're not doing anything different. It makes absolute sense. We think about organisms of other kingdoms. use different molecules, different channels to do similar things, things that are important or significant for them. Here we can't see that very, very well, so I'm not going to go and spend too much time there. These are examples of cucumbers and tomatoes, obviously of interest for the greenhouses in this area. How the phytomelatonin, the use of phytomelatonin, exogenous phytomelatonin that we can use in irrigation water, enables us to reduce stress, heavy metals, thermal stress, 1,000 ways. All that information, all that relevant information, is relevant. Can't see that very well, but you've got a list of all the things that we can do with phytomelatonin, and we're learning that plants do with their own phytomelatonin, regulation of root growth. We saw those patterns of exploration. They're optimized with a good regulation, etc., etc. Germination, optimization of photosynthesis, etc., etc. Now it's difficult for us to change the chip. We can use a different type of anesthetic that a vet used to put an animal to sleep, to operate on it. That same anesthetic, you can use that to put a plant to sleep. What does this mean, putting a plant to sleep? Without metaphors, literally. When you use an anesthesia, when the plant stops being sensitive, that nocturnal the carnivore plant doesn't close to catch its prey. We can ask in the same terms, when the plant comes out of the anesthetic, what is it recovering? You see why we need to get closer to vegetable behavior for cognitive, to referring to cognitive things. The plants are not different to animals. Plantar sapiens instead of Homo sapiens. We need that literally. All we have to do is make that effort to interpret, to approximate, to get closer there, multidisciplinary, to be able to get to the plants and see the plants through different eyes, and see how we can help them without make them force the machinery to go too fast. How do I get them to increase the yield? Not to understand it how the plant would do it. That as we really put ourselves in the situation of the plant and understand what the plant wants, then we can accompany the plant on that process, but we can't put sticks in the wheels. I think now we've gone over time. Okay, we've got some pictures of the combined techniques, observation techniques with time-lapse, insertion of electrodes. And thank you. Thank you. Don't go away now. Now, well, the people are going to start with the questions, the audience. Now we've got a time to get as much juice out of you as possible. There's a question I had since I began asking, how come a philosopher is in this thing, Plantar Sapiens? Well, I ask myself the same question. It makes more sense than it seems. As a philosopher, thinking about cognitive science, psychological science, to understand ourselves, to understand the human mind, the intelligence, what makes us move. And when we think about all that, and we realize that we're not that special, we're not that different. I like to talk about contemplating our navel. Yeah. We are unique, and we've gone over this for many times. It wasn't Ptolemy, it was Copernicus, Darwin, we were just a fruit of the evolution. When you put that all into perspective, you see that maybe studying the plants from this perspective, not only do we understand their behavior, how to accompany them better in the greenhouses or outside in open field crops, but we can also try to understand them better ourselves. This obsession we have with neurocentrism, the neuronal hardware, as if to have neurons was essential to be intelligent or to have sophisticated behavior. Hang on a second, if the plants can sort problems out, then without neurons, then maybe neurons are not that important. So it makes us rethink where is the essence, where is the key of cognition, a bit more humbleness, seeing that there are what other forms of life can do. Maybe we're going to learn how to rethink what doesn't make us so unique. Thank you, Paco. Any questions there for Paco? Go. So going to the mechanisms here, I wanted to ask you, what sort of studies do we need to understand the functioning of plants, how it can vary its function, its normal functioning, to produce more dry matter, starch? It's a collaborative work. Here it's essential to understand that we need to teamwork. So if we were talking about melatonin here, one of the experts in the world is Marino Arnaud. He works in the University of Murcia. He's doing a study of phytomelatonin in their studies. That's the cooperation we're doing. They're the experts, the vegetable physiology experts. They can give us all the technical explanations, what they're doing, what varieties they're touching, the phytomelatonin, all the functionalities that this is going. But all the collaboration we're doing, the collaboration we're doing now, the folding of the leaves at night. These are questions. The induction of the jet lag. It's a question that a vegetable physiologist doesn't ask. What we're attempting to do is to answer the question that they are. Our objective is to reformulate the question, to ask a different question, and in collaboration with them, the vegetables physiologists, to shed light on that question. That's the indication. Same thing happens with the robotics. Why in this case is the Naval Research Office financing us? We've got aeronautical engineers in the NASA. It's changing the question. Let's see how we can turn things around and give it another perspective. What other glasses can we wear to see, well, if our robot, instead of moving, grows, what functionalities do we gain? And the same with phytomelatonin. What can happen if we insert those electrodes, we register the electrical physiological activity? What can we find, for example, when we put a plant, we anesthetized the plant, literally, we anesthetized the plant and registered the electrical activity. We saw what happened there. The neuronal discharge, the trigger in an animal, you can see that in a plant. A carnivorous plant, you touch the hair and it triggers a reaction. When you use anesthetic, it's a straight line. There are no triggers. You block that action. So we can see what happens when you add phytomelatonin. If in the phytomelatonin opening and closing the leaves, we see that response, that electrophysical response, the same that we put a plant under anesthetics. We're beginning to understand that when a plant sleeps, it's not a mere metaphor. That's the sort of extra knowledge that we gain apart from the physiological study. Nothing more. Plantar sapiens. I'm beginning to remember now. Now he's a bit of a plant. Now I'm beginning to understand it. Now we'll do a bit more cookery, and then we'll carry on with Inversolar.
Ahora vamos a ir con un tartar de la huerta. Vamos a aprovechar todas las verduras más o menos.
Now we're going to go into a garden tartare, all the possibilities that we get from a greenhouse. The aubergine, what we're going to take advantage of in this recipe now is to cut it into very small pieces. In the recipe only changes depending on how you cut it. Now we're going to have put a little bit of meat in it. We're going to put some lard in there, bacon, and it's already smoked, and we're preparing this to poach the eggs in a spoon, half a spoonful of vinegar per litre, and the salt allows us the density to go up a bit, and the egg, when it's ready, floats a little bit. A large spoon over the top, and now that's finishing to browning off. Now let's look at the other vegetables. Snack cucumbers, not easy to find them in some places. It's spectacular because it's really, really sweet. A little bit will be enough. Now we're going to take advantage. A small chocolate pepper, a yellow pepper, and we're going to put a red California pepper in. When we see it's all golden, we're going to take it out. Now what we're going to do is put the avocado in to get a type of guacamole going. Okay, we'll put some cuts in there. It's nice and mature, and with half of it will be enough. With a fork, let's squash it down a little bit. Salt and pepper. And there are people do it with spice. We're going to do it with a little bit of spice with these peppers they had in the greenhouse. I don't know them, so I'm going to try them first. It's quite spicy, but it's okay. And I'm going to put a little bit of spice in. Now we can start to include all the different coloured vegetables with different flavours. Chocolate pepper, the yellow, red California, the snack cucumber, put a bit of spice in, some capers too, and dried tomatoes. I like to put a little bit of mustard in there too, Dijon mustard, a little bit of Dijon mustard in there, and we're adding the only element that we've cooked of vegetables, which is aubergine. We're going to squash it all down so it's nice and mixed. Now put the heat up for our water to poach. The easiest way to do it is to put it in a recipient, and now we're going to add the lime with the acid. We're going to put it in the vegetables as well. Now we can see how it's beginning to boil a little bit, and now we start poaching it. We move it around a little bit so all the white of the egg is going to boil. Let's put a bit of our mixture in here. We're going to put the bacon in there, and then we're going to finish off. So when our poached egg is ready, it's going to take a very short time. We'll be able to taste it, and we'll be able to put some onion in there, and it's a plant that enables you to cut it completely. It's all edible, and you can cut them up together, and the shallots as well. Here we see with the salt the egg has floated, and it's just right. And there we are, ready to taste. The test is, okay, if the egg is nice and soft, really tasty. Oh, that really looked tasty. That dish was, these are dishes that are produced here in this greenhouse and in this Inversolar Congress. Now we're going to talk about finding out different things with Anthony Warner. He's a biochemist in the University of Manchester before starting a career in professional restaurants and hotels, and also catering for events in the UK, and in research and development chef. And he worked for more than a decade developing recipes for some of the best-known brands of the country. Frustrated by pseudoscience and misinformation in the food industry, in 2016 he started a blog which led him to the best-selling book, The Angry Chef, and a career in media. 2 more books have followed, The Truth About Fat, Why Obesity is Not That Simple, and Ending Hunger. About his talk, he says diet, nutrition and the sustainability of the food system are often breeding grounds for pseudoscience, misinformation and misunderstanding. With all of you today, Anthony Warner. Welcome to Almeria, Anthony. You can start.
Hello, everyone.
Hello, everybody. Hola a todo el mundo. Muy buenas.
Thank you for
Muchas gracias por haberme invitado. Todos estáis pensando por qué lleva la misma camisa que el agricultor, pero es el único que podía poner. Mi nombre es Anthony Warner, soy un chef, trabajo para fabricantes de comida desarrollando productos, pero también escribo un poco. Here you can see mi amiguito aquí, el chef enfadado. Es un personaje en el blog que escribo sobre la comida. Y yo escribo sobre dietas, la salud, dietas de moda, explorando ciencia alimentaria. Soy bioquímico, tengo un interés en la ciencia y la gente se equivoca mucho con el tema de la ciencia en la comida. Y escribo, además de libros, escribo para periódicos, The New Scientist, Men's Health también. Escribo sobre dietas de moda.
come back to that later. Right, so this is my book that I wrote. This is called The Angry Chef, and it's about diet and health. There's 3 quotes. I'm not sure if you can see them perfectly there, but there's 3 quotes there, and they sort of explain the sort of thing that I write about. So the top quote is from Steven Pinker, who's a professor of psychology at Harvard. Some of you may have, he writes a lot of books about psychology. And he helped me with all of my books, actually, because one of my biggest interests is the psychology of why we choose the food that we do. That's the thing, because I believe in, I write about nutrition and health, but without us choosing food, the nutrition has no importance. The psychology of why we eat the way we do and why we make decisions about food is, I think, the most important and actually understudied part of food science and part of nutrition and part of health. The second quote, let me just get that back. The second quote down there is from a professor of dietetics at King's College in London, and that kind of represents, I'm interested in food science. I'm interested in communication of good food science. I speak to a lot of dietitians and a lot of food scientists about the work that I do and about food writing. I want to get the science communication right, so I kind of make sure that the most important thing is that there's good rigor and scientific sort of value in what I'm writing about. And I've had a lot of support from the people who work in food science and dietetics, and they help me with a lot of my writing, because often I'm saying a lot of the stuff that they want to say, but they're not allowed to for legal and career reasons. Because some of the people talking about diet in the media are people that are not particularly they don't want are not saying very good things. Let me just get my slides back. Okay, go back again. And the bottom quote there is from a chef who people in the UK would know, called Prue Leaf. I had a lot of support from chefs and from other food writers and from people who write about diet, because more than anything, I am a chef, I do love food, and more than anything, what I wanted to do with my writing is take away all the sort of guilt that people were feeling about the food that they chose. And people often get made to feel very guilty about food, and are very guilty about the food that they eat and the diet that they choose. And I wanted to take that away and get back to what is the most important thing in any eating, which is pleasure and bringing us together and enjoyment of food. And a lot of the chefs and other food professionals in the UK, were really quite supportive of that. My second book. Let's go on to my second book. Struggling a little bit. My second book is called The Truth About Fat, which is about obesity and about the issues. I have to point it there. Okay. I was pointing at that screen and the computer's over there. Okay, I am a professional. Right, so my second book, The Truth About Fat, is about obesity and a similar sort of things. It's about a lot of the stuff we get wrong about obesity. It was reviewed in Nature. I'm just showing off that I have a review in Nature for a failed biochemist who became a chef. That's quite a big deal. And my most recent book is called Ending Hunger, and it's about agriculture, and it's about the battle to end hunger and reduce hunger in the world over the past couple of hundred years. And it's also about how we square that with sustainability. How do we make a more sustainable food system, but not produce less food and see more and more people going hungry? I think it's an argument or a discussion we're not having enough. Is that we talk about making food more sustainable, but we forget that if we just reduce the amount of food, people go hungry. Our battle against hunger, I believe, is the greatest achievement of humanity, we don't want to be taking backward steps on that, or despite the fact that the environmental impact of food is very important. The most important thing of all that I learned when I was writing this book, because it took me probably more 2.5-3 years to research this book, the most important thing I learned was don't launch a book in a pandemic, because it creates all sorts of problems trying to sell it. This is the first time I've spoken abroad. Right, so my next slide. Okay, so throughout my writing, I write about the things that we get wrong about food, and there are themes around that. There are similar things in all of it, and I believe they explain a lot of the failings and a lot of the mistakes we make, and they also, understanding them helps us communicate about science better. The first is this: we are pattern-seeking animals, humans, and we like a nice sort of simple story. We don't like complexity. So if there's two possible solutions, we tend to focus on the simpler one rather than the complex one, because simplicity, we sort of evolved as simple hunter-gatherers, where it made sense to look for simple solutions, simple explanations. Sometimes things aren't simple. Sustainability of food systems is not simple. Health and diet is not simple. But we are drawn towards people offering simple solutions. So when a Hollywood celebrity says, it's really simple, healthy is really simple, you just need to avoid gluten and sugar, that's a nice simple solution. It's wrong for the vast majority of people, but the more complex, nuanced reality is that healthy eating is complicated, but we tend to be drawn to the simple solutions. Right, so some simple solutions about sustainability of food system, for instance, are, we look for simple things that we can do, simple things that we can change about our life. So a lot of people will say eat local produce only, and that's that's something you can do, but often it's far more complex than that. Often the reality of what you have to do is more complicated, and just focusing on just eating locally can lead us towards the wrong solutions. It can lead us towards the wrong answers. A second thing that is often touted as a solution for, I'm definitely pointing at that this time, a second thing which is often touted as a solution for making more sustainable food is, say, to go vegan, to cut out meat completely. And we hear that a lot. The environmental impact of meat is significant, and we really need to. Probably most of us need to eat less meat, but actually going vegan, there's good reasons why some animal produce within a food system is a good thing, and it does make sense for us to get away from those simple solutions. I'm going to go old school. Okay, he's going to do it for me from now on. Next slide. Right, going vegan might be a good idea for some people, but the reality of what we really need to do is more complex than that. Cutting all animal produce out of the food system is not necessarily the best way to go. Cutting down is probably a good thing, but that's quite a complex, nuanced situation. So we tend to be drawn to those simple solutions. They're not always the best way to go. If you go on to the next one. Okay, right, so tribalism, the second thing that we get wrong. I'm going to go through three of these. The second one, it was really important, is tribalism. We live in this sort of complex society, and we really like to find groups, and we really like to find groups that we can be in. And these days, I find more and more our dietary decisions and the diets we are on form a really important part of our identity. It's not just being vegan or being on a low carb diet or being sort of a carnivore diet. These are important things that people want to talk about themselves. As we have less religion in the world, diets become more important as a way of telling the world something about yourself. So what you eat, or actually more importantly, what you don't eat, has become a way of telling something about yourself to the world. I interact with a lot of people on social media. I usually argue with them quite a lot, but often on their social media profile, what diet they're on is the first thing they mention, and I think it's very strange that that's the most important thing you want to tell the world about yourself. Go on to the next one. So we tend to organise ourselves into tribes, and these tribes can be different things. They can be religions, they can be just sort of football support, football team support, but often it has become more and more about diet, and that's interesting, but it's also a challenge, because when someone is part of a tribe, and that's part of their identity, it becomes very difficult to argue with them about about diet, because not only if I'm saying that maybe some aspects of a vegan diet are not ideal for someone's health, or some aspects of a really high carnivore type meat diet are not ideal for your health, I'm not just challenging the science, I'm challenging something about people's identity. I'm challenging something about who they are. And it's very important to remember that when you're having these arguments. It's not just about the science, it's about people's identity. And there's also something here which is actually, it's called the unity of the virtues. And it's something that religious scholars will talk about quite a lot. And the unity of the virtues means that when someone believes that something's good in one way, they tend to believe it's good in all ways, and it goes back to us having a belief that God created the world in a particular way, and so if you believe that a vegan diet is the perfect diet, or if you believe that eating large amounts of meat are is the perfect food and believe it's delicious, you'll also have a tendency to believe that it is more sustainable and that it is better for health and that it's better for everything. So if something's good in one way, we kind of always believe it's good in all ways, and that's most of the time that's not true, and it's really important to remember that's very ingrained into our way of thinking, and it's very difficult to argue against it sometimes. So and another one, yeah. So you know, when we have these sort of tribes, you know, people who eat a lot of meat, people who eat a lot of or are vegan, we need to remember that these people are formed in these tribes, and it's you have to remember that when you're arguing. It's incredibly important to remember as you argue with someone that you're arguing about something that's fundamental to their identity and to who they are. It's not just an argument about diet. Okay, so this next one is really important. This is the third one out of the three that I'm going to talk about today. This is the appeal to antiquity, the appeal to how things were in the past. And it's no accident that this is at the heart of most major religions in the world, is some sort of Eden, some sort of unspoilt paradise that humanity has somehow ruined. And this runs a lot through, you'll hear this a lot in diet and health discourse, you'll hear it a lot in people talking about sustainability. You know, people believe that they should eat like their Paleolithic ancestors, and they should base their diet around that, or people believing they should eat like their great-grandparents did, you know, and basing their dietary beliefs around that. And you know, it has a lot of instinctive appeal. You know, there is a reason why most religions have that at their heart. And it just appeals to something about ourselves. We believe that things were better at a certain time in the past. You hear it in politics with Make America Great Again, or Take My Country Back. Go back to that time in the past when things were... And it's almost universally not true that things were better in the past. You know, things are... You know, we have problems now, but things are probably better now than any time in history. In terms of diet, a real appeal to antiquity looks quite a lot like this. It looks like massive amounts of vitamin deficiency, you know, vitamin C, scurvy, and rickets in huge quantities. We've made incredible strides over the past 30 years, 50 years, 100 years in addressing poverty and food poverty and health. And now, although it doesn't feel like it a lot of the time, is the greatest time to be alive in the history of humanity. And we have issues, but we must always remember that that's the case. In the future, we'll have better working PowerPoint slides. The appeal is, so if we go through these, just go through. You know, things like, should we eat like our ancestors? Almost certainly not. You know, if I look at people often say, you know, in diet and health, they say you should eat like your great-grandmother used to. My great-grandmother almost certainly had a terrible diet. She almost certainly got about 90% of her calories from really low-quality bread. There was very little fresh fruit and vegetables. There was very little meat. There was very little dairy. She probably, you know, a lot of people would have suffered from really severe nutrient deficiencies and insufficient diets. You know, most ancestors ate really terrible diets. And we can say the same about sustainability. This is perhaps why I want to talk about this here today. The first talk I've ever done in a greenhouse, by the way. So I don't know if it's. You know, should we produce food in the way our ancestors did? And people say this about sustainability, and it makes sense in some ways because, you know, we didn't have, you know, many of the environmental problems we have now back hundreds of years ago. But, you know, the obvious truth is that you know, we produce far more food now, and we have to produce far more food now. We have a growing population. The past cannot really tell us anything about what the reality of feeding sort of 10 billion people in the future. You know, we have to look at technology. We have to look at new ways of producing. We were running out of food many times in history. We were running out of food in 1890, you know, before we worked out how to fix nitrogen from nitrogen fertilizers from the air. And if we hadn't done that, we could probably only feed 3 billion people. Without science and technology and progress, then it would be incredibly difficult to feed people. You know, as little ago as 1960, mass starvation around the world was predicted. You know, the Green Revolution obviously happened and revolutionized agriculture. You know, so without these sort of massive scientific leaps that were made, and without this massive progress, it would be impossible to feed people. And the past just can't tell us how to feed. You know, we can't look at a nice sort of rural agrarian past and say that's how we should feed people in the future. Yeah, I mean, you know, for thousands of years, thousands of years of human history, right up until very, very recently. 80, 90, 95% of the world's population was free from sort of starvation, was facing the constant threat of starvation. Now it's still high. There's still 800 million people who don't have enough food, but that's only 10 to 15% of the population. There's still progress to be made, but we mustn't forget how far we've come in the last 100, 200, even in the last 20 to 30 years in terms of sort of levels of absolute poverty. So I just want to talk briefly about, we're coming to the end now, but I just want to talk briefly about what we know about healthy eating. I've been writing about food and health for quite a long time, and we know it's actually pretty simple. It's actually not much complex. We know we should eat lots of fruit and vegetables. We know we should eat quite a lot of oily fish. We know we should eat plenty of whole grain carbohydrates. We probably can look at maybe sort of changing eating less saturated fat and more unsaturated fat, and certainly from health and sustainability, eating lots of plant protein, beans, chickpeas, lentils, that sort of thing. That's also really important. But and that's kind of it. Especially the fruit and vegetables thing is very important. Stood here that we need to, if we're going to feed people, it's not just about calories, it's about balanced diets with lots of variety and lots of different types of fiber and lots of different types of vegetables. But that's kind of it. That's kind of all there is to know. And so what do we have to do to get there? Because I believe it's important to have a more sustainable food system, but it's also we need to give people a high quality diet as well. So affordable high quality fruits and vegetables are essential for a better food system. And these sort of systems, as we discussed, are a brilliant way to do that. Reducing global consumption of animal protein is incredibly important at the moment. The protein needs to be replaced with something. You can't just cut out animal protein. Protein is an essential thing in our diets and it needs to be replaced with plant protein. And we must produce more food on less land. It's going to require technology intensification and progress. But if we can do that successfully, there is the potential to continue to feed humanity. The population probably won't get much more beyond 11 billion people, and so we can continue to feed that many people. Okay, and an interconnected global food system is the only way that has been proven to prevent hunger. Transporting food people are very fearful of, and people talk about eating locally. But if you want to prevent hunger and continue to prevent hunger in the way we have now, we need interconnected food systems. We need interconnected trade, and that's kind of it about what works. Okay, so I'm going to do one more thing before I finish. In 1990, there was a student, a psychology student in the UK called Elizabeth Newton, and she did an experiment, very simple experiment, and she took a list of 120 songs, and she put people into pairs, and she gave one person the list of songs, and one person had to guess the song. But the only thing the person with the list could do was tap out the rhythm of the song. I did a song earlier, so I don't know if anyone recognised what that rhythm, that song was. I've done talks all over the world, no one's ever got it, so don't worry. And before she finished the experiment, she did something. She asked people to say, how often do you think she asked the person doing the tapping to say, how often do you think the person doing the guessing will get it right? And the person doing the tapping said they thought they understood it was quite difficult, but they thought they'd get it right. I'm trying to remember the percentage here. Move a slide on. They thought they'd get it right about 50% of the time. But in reality, they get it right about 2.5% of the time. So it's actually much harder to guess than the person doing the tapping thinks it's going to be. And so why do I tell that story? I often tell this, I'm a science communicator, so I often tell this story at the end of presentations because I believe it's an important story. It tells me that if it's incredibly difficult to for someone doing the tapping to understand why the person doing the guessing can't get it right. And that's because when you're doing the tapping, you have the rhythm of the song playing in your head. You have the song in your brain. And the person doing the tapping can't hear that. So when I communicate about science and when I communicate about food science, I try to make sure that I get that same music playing in the rhythm of the person's head. Because otherwise, once they have the music playing, it's very difficult for them, very, very easy for them to actually guess. it was imagined by John Lennon, which is arguably the one that I did before, which is arguably one of the most famous songs in the world. And if you watch this back on video, you'll get that it was. And I just think that's a very important thing to remember, because otherwise, if you don't communicate and get that music playing in people's heads before you talk to them, all they'll hear is just an unconnected series of taps. Thank you very much. I've been the Angry Chef.
Thank you very much.
Muchas gracias, Anthony Warner, el chef enfadado. ¿Te gustan los mini pimientos? Sí. ¿Y ahora qué va a pasar? Ah, muchas gracias.
Okay, you have to, yeah.
Sweet.
Yeah, very nice. Amazing.
We have a question.
Listen it? Yeah. Okay, maybe this is a personal question, but anyway, I wanted to know if you had an opinion about our production system before coming, and if you have a new one after spending some days here.
I don't think I have a new opinion. I can tell you that, what I can tell you is that in the UK, I will often see pictures of the plastic and people saying how terrible it is and how it's shameful and it's the worst thing about the food system. And I'm someone who does understand that that's not the case, and it is when you look at the numbers, because I think you have to understand the numbers. You can't just sort of say, is it good? And you have to understand the environmental impacts, and you have to understand the water impacts, and you have to understand far more. And it's actually what I was saying. It's very simple to say I don't like all that plastic, but what you need to do is understand that complex reality of what is actually going on. And I think when you understand the complexity, you see that it's a sort of system you definitely need. I've seen lots of environmental studies about the carbon impact of food grown in a hothouse in the UK or food grown here and shipped by road, and there's no comparison. It's not efficient to grow a lot of these sorts of foods in the UK, but we want them in our supermarkets, and we need to encourage people to eat fruit and vegetables. So for me, it's the only way to do it.
Anthony, thank you very much.
Wait.
Question?
Thank you very much indeed for your presentation. It was very inspiring. I would like to ask you if, in your opinion, there is someone ruling the food in the world. Is it our mental models or multinationals or science, or who is in charge of food? And also, if we want to change the status quo based on science, what do you recommend us to do? How do we change the mindset of people that are eating today?
I mean, I don't know who's in charge of food. I think it's easy to say big companies are in charge of food. I think when you actually look at how food's produced, it's far more food is produced by smaller producers. I worry, if I worry about anyone in the world of food, it's the influence of meat and dairy lobbies, especially in the US. I think they're very damaging to the cause of good understanding of science and a more sustainable food system. What should we do? I mean, it's difficult. Fruit and vegetables have no PR problem. Everyone knows that they should be eating more of them. Everyone knows that they're a path to good health. So I don't think it's that. But I think it's just explaining, showing people the data and showing people that this is a better way of production. And you're not, if we want fruit and vegetables on the shelf, which we all do, and we want people to consume them, and they want them to be good value, this is what production looks like. And when you look at the environmental impact, it's there's very good data to support that this is the best way to grow that food in Europe. It's really difficult because the people who don't like plastic have a simple message, and everyone goes, yeah, that's terrible, and you see a picture of, I'm not sure the picture from space is the best. The fact that you can see it from space, I'm not sure that's always the best sort of advertising, perhaps, because maybe we should it's very difficult. It's very difficult. You just have to continue to spread a positive message. Too many negative messages in food. Encouraging people to eat more is a positive one. Okay?
Gracias, Anthony.
Thank
Gracias a todos por sus preguntas, por la participación.
Thanks to everybody. Tomorrow.
Decía que mañana hablaremos del
Tomorrow we
plástico,
will
de
talk
esa
about
demonización de este
the demonization of
material,
plastic, of that material,
Débora García,
with Deborah Garcia
en otra de las ponencias.
in another of the presentations in Inversolar. Now we're going to talk about the flavor and the properties of fruit and vegetables in greenhouses.
Los solares del sur de Europa son un modelo eficiente, innovador y sostenible
It's
para
an
alimentar a 500 millones de europeos al año.
500 million Europeans a year.
Millones y medio de toneladas de frutas y hortalizas al año.
Talking,
El 60% de los europeos afirman incluir diariamente en su dieta. Por eso,
This is why the quality of these products
cada vez son más importantes.
is more and more important.
Y en los invernaderos solares
In
del
the
sur de Europa trabajamos con las mejores
solar greenhouses, working
los más estrictos controles
much more closely and working on the quality
de nuestros productos.
to make it much easier.
¿Aún no nos conoces? Somos los Super Veggies.
Mi nombre es Pimiento. Soy fuente de vitamina B6
Ah,
y rica
ya,
en
ya.
vitamina A, C y B9. Yo soy Tomate, fuente de vitamina C.
Me reconoceréis por mi dulce sabor. Soy melón, rico en vitamina A y C.
Nosotros somos pepino, berenjena y sandía. Contenemos vitaminas A, B6, C, folato y zinc.
Me llaman calabacín y soy fuente de vitamina B9.
¡Deliciosas!
Si quieres saber más, sigue al sol.
Somos de Europa, somos
We're- we're-
sostenibles.
We're incredible.
Bueno, pues vamos a abordar ya la última
Well, now
de las ponencias.
we're going to go for the last presentations this first day of Inversolar, the Congress of European Solar Greenhouses. This is the director of the FAO, Malau. Unfortunately, is unable to be with us today physically, so we have recorded her presentation. Just a few days ago, we spoke to her directly from this same place, from the same greenhouse, and now we're going to have watch that presentation. It's going to be the last of this inaugural day. We'll be there at 10 o'clock in the morning, and with Ismahani El Alfi. Now we're going to see the last talk of this final day of Inversolar, the Congress dedicated to the greenhouses, the solar greenhouses, an international event which is enabling us to arrive to consumers of all over Europe, talking to them about the production of the values that their products provide for us. Now we're going to talk to the role that greenhouses, solar greenhouses, can play in the eradication of hunger in the world, an objective which is fundamental in all this framework that we've set up for 2030 around the Sustainable Development Objectives. Now we are going to present the following speaker. It's an honor for us to have in Inversolar with Ismahani El Wafi. She's a PhD in genetics, chief scientist at the United Nations Food and Agriculture Organization, the FAO. She served as Director General at the International Center for Biosaline Agriculture in the United Arab Emirates, where she expanded her mandate to include marginal environments, a concept related to agricultural ecosystems that she helped to mainstream into global research and development. She worked as a scientist in several international research organizations, including the International Center for Agricultural Research in Dry Areas, the International Center for Agricultural Research in Japan, and the International Maize and Wheat Improvement Center. And now we're going to listen to Ismahan El Wafi. Welcome. Thank you very much. I'm very happy to be with you. And for us, it's a pleasure to be able to have you participating here and for having accepted this invitation to tell us. We're following us live from this fantastic greenhouse here in Almeria, and we're doing this online live. How this production method can help to achieve one of the most important objectives, which we have requirements. One of those is feeding as healthy as possible. We're looking forward to listen to your presentation. Thank you very much, David. As we've seen, the presentation will be in English. It's a pleasure for me to be with you today. I would very much like to be with you in the greenhouse, David. Well, voy a cambiar a inglés.
Greenhouse cultivation to enhance food security and to eradicate hunger is very, very big. So food and agriculture lie at the heart of the SDGs, and FAO is the specialized agency of the United Nations to lead international efforts to defeat hunger and improve nutrition while protecting the environment and while generating income through sustainable farming and sustainable agri-food system. FAO actively promotes protected cultivation systems that include greenhouses, net houses, rain shelters, hydroponics, and soil-free substrate-based systems for year-round production that are adapted to different crops, different climatic conditions, different markets, and different technical capacities. So greenhouses are a form of protected agriculture and are an ideal and cost-effective system of agricultural production that couples the need of saving water while protecting the environment and supplying market with fresh, nutritious, and healthy food. In fact, greenhouses can yield up to 5 times the land productivity and 7 times the water productivity of open cultivated land. They provide food safety and high protection against pests and diseases for high-value crops. They are also particularly suited to offset the effect of climate change, since it is based on controlled climate parameters, including temperature, humidity, light, and day length, wind, and carbon dioxide concentration. Greenhouse system increase food safety to minimize pesticide use. And because the efficacy of biology control agent is optimized compared to open field production. So in the greenhouse, we can use much better biological agent, and it works very well because it's under controlled condition. Also, short cycle vegetables, for example, you name it, pepper, tomatoes, cucumber, or different types of lettuce, cultivated in greenhouse are important for farmers for 2 main reasons. The first one, to generate higher incomes from smaller area of land, and second, to generate employment through business opportunities for services such as input supplies, post-harvest services, market linkages, and so on and so forth. Greenhouse systems offer a large range of innovation through digitalization and precision agriculture technologies, through sensors-mediated automated control, climate control systems, for example, soilless culture.
Abordamos ya la última.
A large range of innovation through digitalization and precision agriculture technologies, through sensors-mediated automated control, climate control systems, for example, soilless culture, hydroponics, aeroponics, aquaponics, and the use of artificial soil substrates. Grafting techniques for high-quality seedling production can address issues related to water scarcity, to water salinity, and also improving resistance against soil-borne diseases and nematodes that affect a high-value vegetable crops. When we go even to higher technologies like fertigation system to increase nutrient use efficiency, which can be adapted to the type of production system used in any given country. Of course, there is also the recycling of the nutrient solution, and the renewable energy sources are among other advantages of greenhouse production systems. So it provides us with the ability to recycle nutrient, and if we combine it with the renewable energy, we can really reduce the carbon footprint. So while greenhouses offer many advantages, FAO projects have been designed and implemented, taking into consideration the need to adapt to local context. For example, capacity building, be it publication, training, technical assistance. Second, private sector engagement, because it's an agri-food systems that really are very good for bigger engagement of the private sector, compliance with the food safety regulation, and involvement of local government to provide an enabling environment for increasing greenhouse production systems. Worldwide, FAO has provided technical support in system design and provides technical clearance for greenhouses and protected cultivation system that has been installed under FAO projects and implemented in more than 19 countries. And that includes from Afghanistan, Armenia, Azerbaijan, Bhutan, Cape Verde, Djibouti, Estonia, Eswatini, Georgia, and many more, up to Pakistan, Syria, but also Turkey, Ukraine, and Uzbekistan. In the last 20 years, countries in the Mediterranean climate area have become increasingly competitive producers of greenhouses vegetables. During this time, we have seen a revolution in greenhouse production technology in terms of greenhouse design, type, and quality of the plastic covering material, fertigation, the mulch, the use of high-yielding hybrids and cultivars in terms of varieties, plant training and pruning techniques, integrated pest management, use of pollinator insect, climate control, soil solarization, etc. Only a few years ago, yield of 100 tons per hectare of tomato in a greenhouse was considered a very good performance, whereas today, for growers in the Mediterranean climate area, a harvest of 300 tons per hectare is not unusual. So in regions such as Almeria, crops grown in greenhouse are able to use sunlight more efficiently, thereby offering the possibility to provide affordable vegetables to countries with extreme cold winters or even extreme hot condition. This year, in the context of the International Year of Fruit and Vegetables, FAO and CIRAD in France just released a comprehensive publication that is entitled Fruit and Vegetables, Opportunities and Challenges for Small-Scale Sustainable Farming. And this publication lays out appropriate production practices and post-harvest services to increase the sustainability of small-scale fruit and vegetable production. Fruit and vegetables provide greater nutrition per drop of water used for irrigation in terms of vitamins, minerals, fibers, when we compare them with the carbohydrate staple crop. Farmers growing vegetables have suffered through increased pest infestation and plant diseases, extreme climate events such as excessive heat or cold or flood or drought, soil degradation as well as water scarcity. And as a result, farmers around the world have seen lower harvest yield and higher economic loss in their fruit and vegetable production system. Such biotech and abiotech stresses impact negatively on the livelihood of farmers and value chain actors, and in turn has reduced the availability and increased the cost of nutritious vegetables and fruits to consumers. So smallholder farmers and producers needs to find alternative system to optimize crop production through efficient use of land, efficient use of water, and efficient use of nutrition, and reduce the chemical pesticide use. Let me conclude with 2 points on the future of greenhouse cultivations for smallholders. The first one, FAO will continue supporting innovative practices and technologies, such as protected cultivation systems, through projects and existing programs in the context of small-scale farmers and emergency humanitarian crises to improve livelihood and prevent food insecurity. The second point is that FAO possesses very high-quality technical staff and a pool of experts around the world, as well as partnership with other institutions, with the private sector engagement to address the need of increasing technical capacities of member countries. And lastly, let me remind everyone that FAO Strategic Framework 2022 to 31 put at its center the vision of leaving no one behind through more efficient, more inclusive, more resilient, and more sustainable agri-food system for better production, better nutrition, a better environment, and a better life for all, and producing nutritious fruit and vegetables. It's very key in this vision. Thank you very much, and over to you, David.
Muchas gracias, Ismahan, por esa intervención, por tus palabras. Yo creo que es el momento de plantear también algunas cuestiones, si te parece, ahora en español, para continuar con la conversación. Ha quedado muy claro que la mejora de la... La sociedad en general cree que en esta agricultura una mayor productividad está asociada también a justo lo contrario, ¿no? A lo que son prácticas sostenibles, ¿no? Se ven muchas veces un carácter artificial que no es beneficioso para el medio ambiente. ¿Compartes este punto de vista, Ismahan?
Sí, es muy importante cuando hacemos una producción comercial y que hacemos más inversión en un sistema de asegurar que está sostenible. Pues yo pienso que cualquier tecnología se puede utilizar bien o mal. Cualquier sistema se puede utilizar también de manera sostenible o manera que no está sostenible. Por lo cual pienso que a este punto en el mundo, donde hemos terminado COP26 hace unos días, donde hemos tenido tantas informaciones sobre el cambio climático y cómo está pasando muy rápido, mucho más rápido que lo pensamos, y también hemos tenido evidencia y datos que dicen que todo está de nosotros como humanos, el impacto que hemos hecho en este planeta, por lo cual la sostenibilidad es a must. No podemos discutirlo. Cualquier cosa que estamos haciendo, necesitamos conocer muy bien qué es el carbon footprint, qué es el water footprint, cómo está, podemos cambiarle para que sea más sostenible o no. Y por lo cual pienso que la sostenibilidad es ahora al centro en cualquier cosa que estamos haciendo. Y desde luego en los sistemas agroalimentarios es muy importante la sostenibilidad, porque de un par necesitamos producir más. Es que vamos a tener mucho más gente y esta gente necesita comer. Por lo cual no podemos decir que ya basta, no podemos producir más. No se puede, la gente no puede vivir sin esa comida. Puede vivir sin esa internet, seguro, sin esa televisión y todo, pero comer, es necesario. Por lo cual necesitamos producir más. Ahora, ¿cómo podemos producir más con menos? Allá los sistemas invernaderos son muy importantes porque sabemos que podemos producir mucho más en el invernadero que en open field. Por lo cual ahora, ¿cómo podemos asegurar que está esto sostenible? eso es la tecnología y también el willing, es que los productores y las compañías deben querer hacerlo, deben pensar que es muy importante y que lo hagan.
Ismahan, ha quedado muy clara tu respuesta. ¿Qué crees que se puede hacer para que este modelo tan extendido en la provincia de Almería, en la costa de Granada, tan importante ahora mismo en Europa para alimentar, para proveer de productos frescos durante todo el año a más de 500 millones de consumidores, se conozca más en el mundo y pueda ser realmente una solución para otros territorios? ¿Qué crees que se puede hacer para darlo a conocer?
Pues, sabes, hay muchos países que quieren de verdad tener un sistema como lo tienen ustedes en Almería. Es un modelo muy interesante, donde el gobierno, que sea federal, que sea local, ha hecho mucha inversión, pero también que el privado ha hecho mucho esfuerzo, por lo cual es un modelo donde el público con el privado han trabajado muy bien juntos y han desarrollado una región que fue una región muy marginal a una región muy productiva. Por lo cual yo pienso que el modelo debe estar más conocido y por eso nosotros como FAO lo que estamos buscando es success stories, es un success story que queremos de verdad quizás ayudar a otros países a hacerlo. La idea es que el partnership entre academia, público, privado es una combinación muy importante que no la vemos mucho en muchos países. Y también que sea la eficacia del sistema y también la sostenibilidad del sistema que fuiste mejorando con tiempo. Cuando hablamos ahora en nuestro strategic plan, cuando hablamos de mejor producción, hablamos también de mejor nutrición. Una mejor nutrición es muy importante en este sentido, tener sistemas como los sistemas que tenéis en Almería para producir más. Al lugar, la mayoría de los países, pero también de los campesinos, se van a staple crops, o que sean más fuertes en carbohidratos, porque es más fácil, porque tienen la tecnología que está muy básica por eso. Le gustaría hacer más vegetables, más legumbres y más frutas, pero eso necesita más inversión, más tecnología y más también logística, que sea desde luego con el sistema, con el sector privado. Por lo cual, para mí, necesitamos hacerlo, lo sabemos ahora, necesitamos más legumbres en el mundo, necesitamos más fruta en el mundo. Hay un papel que dice que si convertíamos 35 millones de hectáreas ahora del staple crops, sea trigo, maíz o arroz, a frutas y vegetables, vamos a acabar con la mala nutrición. Por lo cual es un empuje para hacer más, pero para hacerlo más necesitamos un modelo como el modelo de Almería y llevarle a otros lugares. Ahora lo vemos, por ejemplo, en Senegal hay una aumentación de producción de legumbre y frutas, desde luego legumbres bajo invernaderos, que está haciendo muy bien. Lo vemos también en el sur de Marruecos, lo vemos en otros lugares, por lo cual para mí es un modelo muy positivo, que tiene historia, que tiene muchas lessons learned, que podemos de verdad llevar de Almería a otros países y ayudarle a desarrollar este sistema.
Ismahan, está a punto de concluir este año 2021, al que le queda prácticamente un mes. Es el año, todavía, el año internacional de las frutas y hortalizas, declarado así por Naciones Unidas, y ahí la FAO ha jugado un papel muy importante, fundamental. ¿Cómo definiría o cómo valoraría el desarrollo de este año internacional de las frutas y verduras? ¿Se han cumplido los objetivos?
Pienso que sí. Pienso que de verdad, como, sabes, en todo hay una evolución. Y pienso la evolución para nosotros como humanos, para entender el cambio climático e entender la mala nutrición, ha hecho que estamos en un punto donde hablamos de mala nutrición más de cualquier otra cosa. Porque nos hemos dado cuenta que tenemos como 2 billones de niños que no tienen suficiente para desarrollarse de manera natural y que de verdad el daño que está hecho a estos niños cuando no tienen suficiente nutrición es horrible, no se puede aún, no se puede quitar una vez que tiene 5 años y no han tenido algunos micronutrientes, ya está está muy tarde. También conocemos ahora que tenemos casi 2 billones de obesity. So, tenemos el extremo, gente que no tiene suficiente y no desarrollan muy bien, gente que tiene de más. Y por lo cual también sabemos que healthy diet, una dieta que está saludable, está muy costosa y por lo cual los pobres no pueden aún comprarla. Por lo cual pienso que la mala nutrición es a un punto que necesita cosas como el año de fruta y legumbre, como empujar un poquito la gente, empujar el sistema para decir que eso es muy importante, eso es una solución. Esta solución necesita que trabajamos juntos para aumentar de mucho, no de poco. Como he dicho, 35 millones de hectáreas de legumbres y de fruta. Y si convertimos eso en invernadero, sería mucho más pequeño. Por lo cual pienso, eso enseña que hay oportunidad de hacerlo, hay tecnología y hay también ahora awareness. Lo aceptamos, lo entendemos y pienso que ojalá al final de este año que tenemos suficiente awareness, pero también suficiente private sector y gobiernos que quieren de verdad hacerlo. Y por lo cual el FAO se queda lista como agencia de United Nations de ayudar a hacer la conexión entre los países que saben y los países que necesitan tecnología, pero también ayudar a hacer que las cosas se hacen de manera con mucha diversidad. No queremos que todos van a producir la misma cosa como tomate y cucumbre. Queremos que de verdad llevamos quizás mucho más diversidad cuando hablamos de legumbres y cuando hablamos de frutas y tener esta diversidad en nuestros programas, empujarle más y más, porque el punto es que no tenemos suficiente diversidad cuando hablamos aún de legumbres, por ejemplo.
Ismahan, muchísimas gracias una vez más por tu participación, por tu colaboración. Ya sabes que esa invitación a que vengas a esta zona del sur de España, del sur de Europa, está hecha, a los invernaderos de Almería, a los invernaderos de la costa de Granada. Ya es cuestión de cuadrar agendas y que la próxima vez nos encontremos aquí en un invernadero como este para que puedas también ampliar tus conocimientos en torno a este modelo agrícola. Muchísimas gracias a ti, muchísimas gracias a la FAO por su participación en este congreso.
Muchísimas gracias, David. Fue un placer. Gracias, y así puedo comer tomate de detrás de ti.
Bueno, aquí tenemos pimientos snack, pimientos mini, pero también están muy buenos, ¿eh? También están muy buenos. Gracias, Ismahan. Hasta la próxima.
Gracias. Adiós. Chao.